Hello everyone, Bradley Sward here. This is my day 8 solution for the Advent of Code 2024 competition. The problem is called Resonant Collinearity, and almost as always, I am solving this problem in Python. So the problem is you have a grid of squares, you have antennas that are going at different characters. The character indicates a specific frequency that an antenna is broadcasting at. And the idea here is that we need to find what are called antinodes, which are positions, according to their rules, positions in space or in our world where the difference is basically you double the difference from one location to another of the same frequency, and you get an antinode. So that for every two, you get two spaces. You just have to be careful. Like in this case, if there's three of them, there should be six because there's two per pair. However, like this one goes off the screen over here, and then let's see, and then this one goes off the screen over here. So that's why there's only four of them that pop up for the A's. That's just what they're showing you. And so part of the tricky part is, yes, you have to make sure that you're staying within the bounds of the world. You also have to make sure that, when there's three of them, we have to check A versus the first one second, first versus third, second versus third. And if there's four of them, we have to make six choices. And if there's five of them, we have to try all 10, different possibilities and so forth and so on. And the question is, taking into account that you can have an antinode exactly where there's already an antenna of any frequency, how many individual unique squares are there for in your little game world that have antinodes and antinodes? And so, like in this case, here is my data file. You can see there are a ton of different antennae, and there are a huge amount of space. And you're like, well, I need to figure this out. This is going to be a pretty big deal. But here is my code to handle part one. So you're saying, okay, I need a dictionary. Instead of using a grid system for this, I'm going to use a dictionary that keeps track of, for specific wavelengths. The token here is the wavelength. That basically I'm going to keep appending the positions of each one of those locations. So when I run this and I get to here, like in this large example case here, my antennae here are all my frequencies as the keys to the dictionary, and then the values are all a list of lists of positions in space. And so, so that's all of them. It turns out there's not any more than four in any one of these cases, but that's just maybe my data. I'm not sure how they worked it. But you can see there's cases where there's three or four, or I don't know if there's even two, but again, that's just how it worked out. So now that I have my antennas, now I need to go in on an individual basis and go through, for all the zeros, go through all the possible locations. This versus this versus that, this versus this versus this versus that versus this. Six different ways to go by this. Six ways, six ways, six ways, six ways, three ways, and then we just keep going through the list. And that's what this code here does. It says, okay, get me for every key in my key set, then for every, then basically for, here, get my data for that specific frequency, and for every element, go in and just try moving, and like we were showing before, move one way, the other, one way from one of them and one way for the other, taking into account the difference between the X and Y positions. And then we make sure that that position is on the grid, and then if that's all good and everything's happy, we put this in our set of antinodes, and then I don't have to do any other checks because a set will hold all unique items, and so I don't have to do any other work because the data structure will do that for me. And if I do this going both ways, starting from one and then going this way, and then starting from the other and going that way, getting the two positions for each of these. If we do this in a loop after loop after loop, and all of this, we check, do if you'll get the answer, and my answer is 426, and that is what you'll see here. That's my 426 down below. And then you saw that my answer for my second part here was 1359. So let me show you what that means for us. But just to come back one more time here, I get 1359 to get my answer for part two. Here's the code. And now for part two, instead of the antinodes being only in one place, double the distance between the two of the antennae, basically instead of it just being only once, it's like, well, every time we can get from that that difference, As long as it's on the grid, that will count. So basically, like a multiple is allowed. So you could have one here, then one there, and then one there, and then one there. As long as it's still on the grid, as long as it's an equal distance between the squares on the grid, everybody's happy. And what's cool about this is, I can't really show this back side by side, is that I think I really just took the code. I guess it just, this time around, it got really lucky for me. I just took the code, and like this part here, instead, you can see that it's removed, but then I moved it down to here, and then like the if statement became a while loop, because all I'm really doing, I'm checking starting from my position, and I'm going whatever the distance is, whatever the distance is, whatever the distance is for the differences each time until I run out of space and I go off the grid, and then I'm done. And then I do that for the other one where I start from the other position and I work my way the other way until I run out of space, and I just do the exact same stuff as I did before, and in this case I get the answer of 1359. So those are my solutions to the problem. I don't know, like as always, I don't know necessarily a better way, or you can't, sometimes you can see it, sometimes it's just not worth the effort since I have the problem, it's solved. It's not my job to do these every day and every moment. But if you know a better way to do things, I'd always love to learn too. So I hope this helped you out. Hope you guys have a great day. We'll see the next problem in a couple hours here. Take it easy, everybody. See you then.